we are now live. And then it does this lovely thing. So I'm just gonna and then switch over to this really quick. So can't hide that. All right, so using ECS as one of your services, I would love to find out what you're actually deploying. That'd be awesome.
It's funny, as the lunch and learn was just on that last week.
Andrew Porter. Anyone who knows me calls me Andy. Or has at least met me once. What we call electronics, we create traffic systems. We're all up and down the freeway. We're at a lot of intersections on.
Like sit on the lights, the things.
Ours are actually.
Oh, they're on the back of the signs that. Like carpool thing.
Not those either.
Oh.
Yeah. So on the freeway,
I got them shapes there.
on the freeway, ours are like mounted high on a pole. And they shoot a radar beam all across all the lanes of traffic.
So what's the purpose of the radar? Is it like counting traffic, speed, or?
Yeah, we do. We can do counts. We can do speed, direction.
Microwave your burrito as you go by.
Yeah, but there's an interesting story where there's an old lady in California that wanted to sue us because we.
Because you in contact with the beam for 1-800.
There was a sensor across the street from her house that was pointing at that. Our devices actually emit less energy than a microwave oven. So
Beautiful.
yeah. Back, I'm usually under the handle party drone, which is an anagram for my name.
There'd be an awesome story.
So who knows what Docker is already? Some of you must know already. So at least
I've heard of Docker.
all right. So I'll probably just kind of skim through this really quickly. It's basically a lightweight platform for building, shipping, and running your applications. Because there's containers, and it's the containers that get moved around from one environment to the next. And some of the jargon that Docker, you hear a lot with Docker is you hear about images, you hear about containers. So I actually have a slide for that. So an image is basically a blueprint that defines your application needs, everything that it needs to run, and all of your application code and everything. Structure for your container or a class.
Recipes and everything.
Similar, but not quite the same, because the chef recipe is something that just gets executed in order to provision and deploy.
Okay.
This is more like defining a class in Ruby or other languages. And then a container is actually an instance generated from the image, but an instance of your class.
Okay.
And you can actually generate multiple containers from the same image. So yeah, there's often a lot of confusion about what's the difference between a container and a virtual machine. Basically, machines, you have a server that has infrastructure. It's got networking and CPU and memory and all the hardware. And then you have an operating system installed on that server, and then this sort of virtualization layer, like hypervisor. That's from that, you have machines, and every virtual machine comes with a completely independent operating system, libraries and binaries that your application needs to run in that virtual machine. So you can have multiple virtual machines running on a single server. Docker basically gets rid of this operating system, uses the Docker engine layer as virtualization, and then your Docker containers have all the binaries and libraries and application code that are needed to run your application without the added overhead of this operating system. One analogy that I heard at Microsoft Ignite was virtual machines are like a neighborhood of houses. It has its own services, plumbing, water, electricity, and all of that. And so there are ways that you can customize your house and everything. Think of your application as just a room. Virtual machines are like having a room in a house. Containers are more like having a room in an apartment complex. So you have one building with all of the services that are necessary, and you just have room in the apartment complex. I don't know if that helps, but
One of the ways of explaining it was imagine if you were able to package your app up into a single executable and run it on the server, and that's sort of it's kind of an app on a host server.
yeah.
So they're still utilizing the same shared resources, but they're namespace.
Yeah.
Does anyone concerned about, so rather than trying to explain what Docker, that engine, that cloud-like blue bar, does anyone care what Docker actually is? Otherwise, we could probably move on.
Yeah.
Because there was some things that you said, and it's like, well, if we won't care, we should probably dig into that. But engine bar is like Rails. There's a lot of math going there. Looked into it, it sounds like we're using it. Yeah.
I mean, it sounds like the important parts are gonna be, you know, performance stuff and
Things don't quite translate very well, right? It's like machine, and you put some virtual machines, you have some limitations, right? It's big and heavy. It's a little bit off of that, depending on what you're doing.
what's the trade-off?
The limitation is still whatever that machine is, right?
Yeah.
So if you have a 4-core, or say you have a single core, well, you can only run two things parallel on that machine, right? It's an OS, it's a little heavier, needs more memory, a lot more. You got 2 OSs on there. They can probably both run okay. Running 2 containers, 3 on there, right? And depending on what is running, if you've got a database app and your app, right? It really comes down to what you're running on there.
Anyway, with the other scenario.
And the Docker engine isn't actually a runtime. It's Linux. The engine is prepping. Apps don't run inside of Docker. Linux that has been set up, and a bunch of things that Linux has, just like Jails has on the BSD platform, right? It's very similar. Docker helps solidify and make it as good as Jail that Solaris had for isolating your applications. That explodes into a much more complicated and technical.
There's a whole rabbit hole we could go down.
Yeah.
There is
That place scares me, so.
thing that you might run into that has happened. You're all running into the same Linux kernel, so the same system, so you can have a situation where you have different versions of like Windows or Linux or different versions of Linux. You're all the same kernel. So if you're running 2 different containers and they both need a slightly different version of the Linux kernel, one's not going to run.
Yeah.
Like one is shit. So you sort of have to arrange your
So
your
it's not,
systems.
it's not good if you're trying to set up a set of machines to do QA on multiple OSs.
Here's the reality, so as far as the two places I've used Docker at, I have one container on one thing, whether it's a virtual machine or, well, physical, we've done a little bit more. Usually in the virtual machine, the Amazon world, you're gonna have one container per instance. Different, but having this notion of having two different containers, we haven't done.
We run 3 or 4.
Are you doing that then?
They're generally the same code base, but they're running different processes.
So, I mean, like
I'll
your
run multiple
database
websites.
and an application.
Well,
Multiple websites on a Linux box.
Yeah.
Really, the benefit is portability. I don't know that the virtual machine works very well, like the comparison, because it's more like the application where it's a way to containerize your application and pack it up. And startup is really fast, for example.
Right, so you do parallel.
Yeah, for us, it depends on the resources, but generally the way it's allocated, we could probably have 2 or 3 containers on a virtual machine. Those are easily spun up and spun down with an orchestration layer. We're using Amazon CCS for that. It makes it really easy for us to do deployments with 0 downtime, for example. Pull back, that's a pretty painless operation. It's not the same overhead as starting up.
Plus, you can take those same images and run them locally, and essentially have the production environment as close as you can on your local configuration or virtualization.
Yeah. The benefits of having Docker is that, you get good developer onboarding. When new comes onto the team, it's download the code base, and as long as it's Dockerized and they have the Docker engine installed on their teams, they can bring the app up and be up and running in a matter of minutes.
The same kind of thing with Chef, but
Yes.
But faster.
faster with Docker.
Yeah.
Oh, because it's an image, right?
It's already running.
Well, Chef is more of a deployment automation tool where you define like how you want your servers to be provisioned.
Right.
And getting your code from one place to another, things like that. And so you can still use Chef to deploy your containers into production.
If you hate.
So yeah, so it's not the same
I'm not
thing.
married to Chef, I'm more.
Well,
familiar
it's
with it.
just not the same thing.
Right, okay.
So, yeah. Platform runs on a variety of different platforms, Mac, Windows, Linux, and they have versions that allow you to deploy to AWS and Azure. Microsoft just built native support into Windows Server 2016 that they announced last year.
Which, just like Mac, the new Mac Docker, also means that inside of Windows. It's completely still based on Linux.
People integrate with Windows native virtualization.
Yeah.
Yes. So it's using their hypervisor instead of.
But it's still running inside of Linux.
Well, so yeah, it's for development, but for Windows Server, not exactly the same thing. It's supposed to be like native support for Docker level. That's what they said.
Right. They'll look into that.
So from here on out, I'm just going to show you how I use it. So the first thing to do is actually so you just go, or you download and install it, and then it'll run a service of startup when you boot your machine. If you want, here's some of the the options that you have for it.
To like a virtual box or
No.
something in the background.
So you don't need VirtualBox or anything. So it uses whatever virtualization technology is built into the platform. So Linux, I mean, its roots are in Linux, so it starts there. Uses hypervisor and things. And then pull up my notes.
So they've built their own container system, and the API is compatible with Docker's.
Yeah.
Microsoft has.
Mhm.
Or they built it.
I don't know how
Or the like container.
they built their own.
Now, in this case, since, you know, with virtual machines, you can use the kernel of the guest operating system, but with Docker, it relies on the kernel of the host operating system. So you may only be able to run containers on a Windows server. I'm not too clear about that either.
They took the Docker CLI, which is Go, and they compiled it to Windows, and then made sure that all the API calls work with their Docker at the CLI level in PowerShell on Windows. The APIs all match up against their own container system.
Okay.
So they're handling the root stuff, because Windows doesn't have root, right? There's no way to root a system in Windows until they've actually built that. And then process tree segmentation as well, which is the other big container thing.
Yeah.
Good for them.
That's amazing.
They-
All right. So Docker's installed and it's running. That you get two basic commands. Docker command and another command that I'll get into is Docker compose as well. With an app. What we're going to do is
This is a Docker terminal shell.
this is a terminal shell. Docker's installed as a service, and there's a command line utility that's installed on the system.
So this is a regular terminal shell.
Yep, it's just a regular terminal shell.
Docker's just a command line.
So we'll just create the standard blog application. And then change into that. Then from there, I'm just going to use my text editor. All right, so first thing we need to do is we need to create a Docker file. And in that Docker file, Docker has a whole service online called Docker Hub, where their own images that they've built for different things.
And it's tightly coupled to S3.
It's tightly coupled with S3.
But that's a feature.
Specifically in the Northern Virginia servers.
It actually didn't have a huge problem today, so it must be contributed, but we were issues.
We had a terrible time. Just and for a while.
So the first thing you put in the Docker file is an image, basically a base image that you want to start from. So you can pick Ruby 2.4.
And in this case, Ruby is the name of the image, and the colon 2.4 is the version of the image. Is that right?
Yeah, they say, they talk about it in terms of like an image and a tag. Because another tag would be, you could put Ruby : latest. The latest, whatever is tagged as the latest version. It's usually a good idea. They recommend that you put yourself in there as the maintainer of this image that you're creating. Did I? Yes, I did. Hey, yeah.
What was that? That's another embedded Star Trek reference. Michael Dorn, although. Yeah.
So the next thing we're going to do is we're going to run a command in the container once we get it to update all the packages, and the QQ option is just to make all of that output really quiet, putting a bunch of stuff out to the terminal. And then we're going to everything, and again we're going to make it quiet. If we're
What it's supposed to update and install.
where is it getting it from?
Yeah.
So Linux, the Linux operating system has package managers on it.
So it's just doing the default.
Yeah.
That's for Devin, if you're just working with like a Red Hat, that's what it looks like you uninstall or you update.
Basically, home, real update.
Yeah.
Yeah. And by putting a
This isn't doing anything to your Mac. This is just inside of the
Oh, so this
container.
is inside of the namespace.
yeah, I mean, so right now I have created a directory on my Mac, and we're working in my Mac right now, defining this Docker file.
On the Mac, on
Yeah.
the Mac, Docker is both a VM and the container ecosystem things, because you can't run Docker natively in Mac.
It is not good.
It's totally obscured. It used to be a lot more complex. Now you just download the Mac Docker and it obscures all of that. It takes care of it. In Linux, but you can work from your folders and all of that.
So I'm just installing some things that we'll need. Build Essential, when it installs gems, any gems that need to be built, it'll need the Build Essential package. The libpgdev library use PostgreSQL as a database. And then you also need a JavaScript runtime on the server for Rails to run. You can set variables in your Docker file. So we're going to set this one to set the application directory equal to blog.
Path, or is it
It could be a relative path, but this is going to be blog based off the root of the container. Yeah. So this workdir command, it basically sets the working directory in the container. And so now any new instructions that I give it are going to be run within the context of that folder, basically. So it's like changing into that directory and then running the new commands. And tell the container to make that directory. Actually, we're going to make the directory first, and then we're going to change into it. Then we're going to tell Docker to copy our gem files. The order of arguments here is that we're copying from our machine.
The gem file star means the host machine, your Mac.
Yes. And more specifically, it's going to look for that file within the folder that this Docker file sits.
Can't grab anything outside.
you can run
I'll build the contents.
the working directory that the Docker file is in, that's it. You don't have access to the files.
Yeah.
For that,
Your root inside of the container it is not the same route
Right,
of the.
that's kind of what it was.
And there's no way to break
It's
this.
kind of a virtual file system.
Has its own file system, yeah.
In theory, yeah, it virtualizes some aspects of it.
So now I just configure bundler so that it can faster. Then have it install all the gems. Then we're going to have it copy all of our code, our current directory on the Mac, the application directory in the container.
One thing that's cool about this, each pink operation you see there is sliced up and layered. And this, he's gonna build the image that gets cached. So not only do you have like a linear build process to set up your environment, it doesn't have to install it every time, whereas like a VM, something like Chef, that has to run every time.
Right.
So,
Unless you save the image of this VM, just start it from that point.
yeah,
Yeah. So every time you run a build command, it goes through this Docker file, and like he said, for every line it creates that's like a layered portion of the container. Every subsequent time, like when you make changes and you rebuild, if some of these layers haven't changed, then it just skips over them and uses what's been cached.
you can hop into it.
So it caches it sequentially. An image basically of each step.
Yeah. So the volume command basically exposes part of the container operating system. And I'm exposing the public directory so that when you have a web server that serves static files, it serves it from the public directory in your app. So we need to expose that directory so that other things can see it. And then the last thing, Docker file, is the command that gets run once the container comes up. And since this is a Rails app, use Puma. And the next file I'm going to create is called Docker compose.yml. So this is it's a YAML file. You can use Docker Compose to basically orchestrate and work with at once. And you'll kind of see how it plays out as we get into it. So 3 now. So there's a services section, and these are where I define all the services. I usually put them in alphabetical order. So for our application, we are going to build what's in the current directory. And so this is going to look for a Docker file in the current directory and then build that. And then in the Docker Compose file, I can actually override this command if I want to. So I'm just going to do server command and bind that to port 3000. Or put that on port 3000 and then bind it 4 zeros. And I don't understand completely, but the reason for doing this has something to do with the way that localhost gets resolved. Bind it to 0000, then in some systems it just won't be able to resolve what localhost is and know that it's the container.
That's telling to bind to all interfaces. And that's why local host is resolved to the
127.
loop.
Yeah, okay,
Yeah, so
yeah.
it's a interface on the network. But if you were to just put in there, local host would work fine.
Okay,
And you can always test that just by running it from the command line.
yeah. So the next thing I do is set up volumes. So it's colon and then in the container. So the current directory, it's going to be blog/blog. And then public in our code base here goes to public. And then again, for this port section, I'm just saying that port 3000 on my computer maps to port 3000 on the container. This depends on section. You tell it that this service is going to depend on another service. For the database, I call it Postgres, just in case you want to have both a PostgreSQL server and a MySQL server running. So for the Postgres, I don't need to do anything special with that, so I'm just going to grab the official PostgreSQL image off of and they actually have a lot of the like official images. They create a really lean version of Linux, so it's the smaller file size and everything, and it's usually based on a version of Linux called Alpine Linux. Not doing anything special with the database, I just use that version of it. Then we need to expose the ports. And I do expose the database volume. I put that in my temp, I create a temp data directory. And then that maps to container where the database. And you can look this up for different databases. It'll usually give you this information for you to map to in the container.
I'm going to cover how you then persist that data in production to get to an EBS thing or something like that. Because if you deploy this to down, it would go away.
Yeah, don't do that.
Yeah.
Containers are supposed to be fairly stateless and simple. Yeah. There's some solutions that help.
All right, so this is a pretty basic Docker Compose file. The next thing we need to create is our gem file. We want to create a Rails application.
And these are all on your Mac file system in that out here, right?
Yep, yeah. Source Ruby gems, and then gem Rails. And then how to do this, it said that I had to have an empty gem file lock file. Okay, so I haven't tried it out.
So you had to touch the file before you
Yeah, so it's empty. It doesn't have anything in it.
Like it can't create new files, it can only redefine existing files maybe.
Well, no, because
As long as it's fun to install.
Yeah, those commands, you could just leave it.
yeah, I could just leave it off. Oh, one more file I'm going to create, and that is a Docker ignore file. It's just like git ignore. It's just a list of files that Docker will ignore as it copies from your machine into the container. Store. It doesn't actually need the Git repository. Docker ignore. Yeah. Log directory, the temp directory, because those will get created automatically anyway. It doesn't need the Docker file and or README. All right. So now on the terminal,
Moment of truth.
we're gonna use the Docker compose command. We're gonna run against the app server that I defined in there, and then just the Rails new. So we're gonna create a new Rails. PostgreSQL, overwrite any files that exist. So that would be the gem files that I just created. Then, yeah, when it creates the Rails application, it'll write over the top of those.
You got a typo in your
Thanks. And we're going to tell it not to. So one of the first things you'll notice is that it actually created a network, a named network for our application. And right now, the prefix for these is based off of the name of the directory that we're in. That's why it says blog.
Up another terminal and typed in ifig. It's not gonna be that on that side, is it? Not sure the name, but
Is that British? Oh, you're right. Well, 10, 0, and 1 are your network.
Yeah, I'm.
This is in user space, so I don't know. Yeah.
you shell into.
It also might be the network connection may have fallen down.
Well, that's because it's not.
If you need to plug in with the Ethernet cable, you can plug the Wi-Fi access.
Is that going to give me, like, are all these ports hot?
Only the one that has the plug-in. The rest of the ones that fall in the